Hi everyone! Today, let's review some Calculus 2 application problems of integrals. Okay, and you remember we learned the trapezoid rule and the Simpson's rule, so today we're going to use those methods to approximate the integrals. Okay, first applications. Volume of solids of revolution. We can use disk method or shell method or washer method. Okay, and here, if you can remember, f is the function. Alright, so this method about the x-axis, let f be continuous with f is positive functions on the, non-negative functions on the interval a to b. If the region R bounded by the graph of f, the x-axis at the vertical lines x equals to a and x equals b is revolved about the x-axis, then the volume of resulting solids of revolution equals v is integral, definite integral from a to b, pi f squared dx. Why is that? Well, we can cut it into a small rectangle, and then we think about what happened to the endpoints when we rotate about the x-axis. We get a disk, right? For how do we calculate the volume of a disk? Well, we need, this is like a cylinder, so the volume of a cylinder is pi r squared height, right? So pi r squared height. And here r is f. So in this case it's pi f of x squared, and h in this case is dx. And then when you sum up all the slices, this is the integral we get. Okay? So this is the disk method. We also have the washer method. So if we have two functions, f and g, they're continuous, with f is greater or equal to g greater or equal to 0 on the interval a to b. Let R be the region bounded by f and g, and the lines x equals to a and x equals to b. When R is revolved about the x-axis, the volume of the resulting solids is the following. So we can also draw a small rectangle, and then we imagine what happens if we rotate about the x-axis. We actually get annulus, right? So we have the big R and we have the small r. Then, well, what's the volume of a slice? That's area of base, which is pi big R squared minus small r squared times height. Height is dx, and big R in this case is f, small r in this case is g. So that's why we come up with this formula. So far, so good, everybody? Okay. Now, let's look at our example. Use the composite trapezoidal method with n equals, so for MATLAB, we're going to calculate 24. But in class, if we want to calculate by hand, let's do 4 subintervals to approximate the volume of the solids formed when the region bounded by f equals sine pi x squared e to the minus x over the interval 0 to 1 is revolved about the x-axis. Okay, so let's draw some picture. So let's say we don't know what it looks like, but when x is 0, sine of 0 is 0, e to the 0 is 1. So it is 0 at 0. Okay, at 1, sine of pi. Oh, sine of pi is 0. Okay, so it's something like this. 0 to 1. Okay, so we have, this is the function, and we want to rotate about the x-axis, right? So the formula v is sum of pi r squared dx, because the width here is dx. So the integral from 0 to 1, pi r is sine pi x squared. And then e to the minus x squared is the same as e to the minus 2x dx. Okay, so we want to evaluate this integral. Okay, so what we do here, we use the trapezoid rule, and so we have 0 to 1. We divide it into 4 subintervals, and this is 0.5, this is 0.25. This is 0.75, right? By the trapezoid rule, we have to figure out h. H is b minus a over n. B is 1, a is 0, n equals 4. Okay, so this is 1 over 4. And the trapezoid rule is, if you can remember, h over 2, f of a. So here this is a, this is b, and here this is x1, x2, x3, right? I want to write down the rule in general, then you can remember. So trapezoid rule, the first endpoint and the last endpoint, f of a and f of b, they're just one copy, and the interior points x1, x2, x3, f of the function value has 2 copies. Okay, so let's see, h 1/4 divided by 2, that's 1 over 8. F of 0, well, what is the f in this case? Well, f is not the sine pi x squared e to the minus x. I should not use f. Let me use g, because we want to evaluate this integral. Okay, we're not talking about the area under the curve, we're talking about the volume of the solid. So this is the function, this is the integrand, right, that we're interested in. So let's don't use f because it's confusing. Let's use g. Okay, then what is g of a? So g of a is when we plug in x is 0, sine of 0 is 0. And then 2 when we plug in g of 0.25. Okay, and g of 0.5. And then g of 0.75. And g of 1, so 1 squared is 1, sine pi, you know, sine function look like this, at pi is also 0. Okay, so what is that? Here we got 2g of 0.5, so we have pi sine squared pi 0.25 square e to the minus 2 times 0.25. Okay, plus the same thing, but we place 0.25 by 0.5. Plus the same thing, but we place 0.25 by 0.75. Okay, what is this number? Well, this number we get, let's see here. Calculator here. Alright. 1 over 8. And then times 2 pi times sine, okay, let's do, I'm not sure whether you can know how to, so, sine square, I forgot square here, pi, no, pi is inside, pi, and then times 0.25 square, and the sine is also square. Okay, and then we have e to the negative 2. By the way, in your calculator, the negative and the minus sign, they're different stuff. E times, maybe I need a parentheses, otherwise you think this is 0.25. Yeah, so far so good, everybody. Okay, okay, am I right? So 2 pi sine of these guys square. Let me put a parenthesis here because I'm afraid it will get confused. It's sine of like a pi. It's the pi and then 0.25 square. With the parenthesis, it will be more clear. Okay, so next, I'm just copy this guy and paste here. We place 0.25 by 0.5. And next, we copy again. But we place 0.25 by 0.75. Okay, and let's see what is the answer. Hi everyone, I realized the number is super small. Then I've realized I have a mistake. See, this is degree mode and we need radian mode. Okay, after we have the calculator set in the radian mode, and this is our answer, 0.3311727. Okay, so the answer is what is that again? 0.33117, and then 27122. And make sure when we input the trig functions, the calculator is in the radian mode, because that is usually the mistakes come into play. Right, we type the correct things. Actually, I check multiple times, and then the number doesn't feel right. And at the end, I realized, oh, it's degree. We should have it set to radian mode. Okay, so this is our answer, and we can also use MATLAB or Octave to check our work. So open Octave. I already typed it to check our work because when I was trying to figure out what is the mistake. So the syntax is trapezoid, right? Inline function, and then we have pi, and then we have sine pi x squared times e to the minus x, this guy to the square, right? And the left endpoint is 0, the right endpoint is 1, and we divide it into 4 subintervals. So you can see the answer is 0.33117, which agree with our answer. Okay, and let me see, can I print screen here so that you can see how we check our work in MATLAB? Okay, so let me move this guy here. Okay, and let me also print screen the answer, then you have that in the notes. Okay, so I also move it here, and you can see it matched with our numbers. And actually, if we increase, let's say, if we increase to 40 steps, well, the answer is 0.33071. Okay, we will say this is maybe the true values up to 5 decimal places. So far, so good, everybody? And our answer is already quite close. Okay, so that is the trapezoid method. Let's continue. Okay. Next is the surface area of a solid. Okay, so in our Calculus 2, so if you took Calculus 2 in Indiana Tech, we cover the volume of a solid, we cover the disk method, washer method, and the shell method. Okay, and we also cover the arc length, but we didn't cover the surface area of a solid. Okay, but it's very easy. Let me draw the picture. So this is F, right? And think about if we rotate this F around the x-axis, we get a surface, right? And here we want to calculate the surface area. So think about it. This rectangle, when we cut it and when we rotate about the x-axis, we get a surface like this. Okay, so it really looks like a cylinder. Do you agree? So what is the surface area is just like we cut this cylinder and then we open it up. It becomes a strip, right? Okay, and then what is this rectangle? Well, the length is the circumference of the circle. So this is 2 pi r. Okay, and however the height, in order to be more accurate, the height is not dx. Think about it. This is dx, but if our, let's say if our rectangle is right here, this surface, this guy is the surface, right? And it's quite off if we just take the dx. So this guy is actually the s. S is the arc length parameter. Okay? So, and the relation between the arc length parameter and the dx. Okay, let me draw a picture here. So, this is dy, this is dx, ds is right here. So ds is like square root of dy squared plus dx squared, right? By the Pythagorean theorem. And we can actually factor out the dx squared. Then we have dy dx squared plus 1. And we can factor out, we can pull out the dx squared outside of the square root. And then it becomes, well, this guy is actually f prime of x squared plus 1, right? This is the inside the square root. And then we have the dx is outside. So that's why here, oops, sorry, I pressed the wrong button. Okay. So h in this case is like ds. So that's why the surface area equals sum of those strip. But each strip is 2 pi r times ds, right? So that is 2 pi r. R is the function, and ds is a square root of 1 plus f prime square dx. Okay, that's the s and dx. Okay, so far so good, everybody. So this is the surface area. Let's look at example 2. Use composite Simpson's method with n equals, let's do 4 in class. Okay, but with MATLAB we can do as many as we want. Let's do 4 subintervals to approximate the surface area of the solid form when the region bounded by e to the x over 0 to 1 is revolved about the x-axis. Okay, so e to the x looks like this. 0 is 1, and 1, this is e, right? And when we rotate, we get a surface. Okay, so surface area 0 to 1, 2 pi f. F is e to the x. Square root 1 plus, well, you know what? F prime derivative of e to the x is also e to the x. So even though I put e to the x here, but what I mean is actually the derivative, okay? And in general, the derivative of a function is not the function itself. So e to the x is just a special case. Okay, so I want to emphasize that because I don't want you to plug in f there. This is actually f prime. And e to the x squared is like e to the 2x dx. So far, so good, everybody? Okay, so this is the integral that we want to calculate. And by the way, in general, after this formula, you can see this integral, we're not able to integrate and get a nice formula. Okay, that's why the numerical integration method is super helpful. Okay, so here let's draw the interval 0 to 1. We divide into 4 subintervals. So this is 0.5, this is 0.25, this is 0.75. And do you still remember what is Simpson's rule? The integral is approximately, by the way, what's h? H is actually the step size, right? Is 0.25. Or you can think of it as b minus a over n, so that is 1 over 4. And Simpson's rule is h over 3, and then, oh, we don't use f again. Same reason, we want to calculate this guy. This is g. So we use g of a and g of b. They have one copy. And the interior points, we have 4, 2, 4, 2, 4, right? Sorry, 4. And then we have 2. And then we have 4. So far, so good, everybody? Okay, so h is 1/4 divided by 3 is 1 over 12. G of 0, let's see, 2 pi e to the 0 square root 1 plus e to the 2 times 0. And then, so this is g of a, right? And then 4 copy of 2 pi e to the 0.25 square root 1 plus e to the 2 times 0.25. And then we have 2 times 2 pi e to the 0.5 square root 1 plus e to the 2 times 0.5. And then we have 4 copy of 2 pi e to the 0.75 1 plus e to the 2 times 0.75. G of b, so 2 pi e to the 1 plus e to the 2. Okay, so let's plug this in our calculator. So calculator, here we go, 1 over 12. And then times 2 pi, and then e to the 0. Actually, I know e to the 0 is 1, but I just want to type it one time, and then we can copy and paste. We don't need to retype it again. So this is e to the 2 times 0. Oops. You see? You see what happened? When I just type it, it becomes this. So what we need to do, I think we need to put parentheses around here. Then we can continue to times 0 here. Okay. And right, that's good. Plus 4. Let me close this parentheses. Okay, now we can copy and paste. 4 times 2 pi e to the 0.25, and then here 0.25, and plus 2 copy of that, and then we have 0.5, 0.5. You see what we're doing? We just type it once, and then we can copy. If you are using your actual calculator, you can enter one formula, and then the next line you can start it. But whenever you go back to the previous line, it will show up there. Okay. And then here we have 4 copy of. Let's see, where is it? Okay, here times, and this is 0.75. There's something on both sides. Oh, okay. And also plus, oops, here there's 2 dots. Okay. Plus, oh, just that guy. And this is e to the 1. Oh. Okay, and this is 2 times 1, just 2. Okay, so the answer we get is 22.9498. 22.9498. And let's see. 0655. 0655. So far, so good, everybody. Okay, now let's use MATLAB or Octave to check our work. So here we want to do the Simpsons method. So not trapezoid. Other way. For interval 0 to 1 and the functions. What is the function now? The function is 2 pi. So 2 times pi. Don't forget the times. And then times e to the, so e is exp of x. And then times square root sqrt of 1 plus exp 2 times x. Okay, let's see. Are we good? Okay, we're looking for Simpsons method. So SIMP. Oh, do we forget something? Inline function 2 times pi times e to the x times square root of 1 plus e to the 2 times x 0, 1, 4. Okay. Is it because of the square root? Let's see. Square root. Let's see. Okay, it's not the square root. Function bodies must be single expressions. Do we? We missed the parentheses. You know, sometimes the parentheses will cause problem. Yeah, that is the parentheses. So parentheses is very, very important. Okay, and so our answer is 22.950. And does that match with our answer? Yeah, that matches with our answer. Let me copy here. So now you can see it. We check it through using MATLAB. Okay. All right, so far so good. So with MATLAB, we can now increase. Let's compare with the trapezoid. Okay, trapezoid will give us 23 point something. Let's see what's the true value. Okay, true value will get 40. See, the answer is 22.943. And you can see the Simpsons method, even though just 4 subintervals, we get pretty close answer, 22.950. But the trapezoid method, we get 23.350. So we know Simpsons method actually converge faster than the trapezoid method. Okay, we get a closer approximations. Okay, let's continue. At length. Okay, let f be a continuous first derivative on the interval from a to b. Then the length of the curve, well, we just show the surface area, right? So this piece is actually ds, right? This is ds, this is dy, this is dx. So at length is like sum of ds. So that's why it's sum of square root of 1 plus dy dx squared times dx. Okay? So this is the at length formula. If we consider x and y, they are functions of t, then we'll get square root of dx dt squared plus dy dt squared inside the integral. So far, so good, everybody. By the way, if you completely forgot all of these, welcome to, please go to my website and then you can click my Calculus 2 course. And then these applications are in chapter 6. So shell method is in 6.4, disk method and washer method is in 6.3, and the outlength is in 6.5. So you can click on the corresponding notes and videos to read and watch. Okay? And of course, if you have questions, please come to see me. I'm very happy to help you. Okay, let's use the composite trapezoid method with n equals, let's also do 4 subintervals to approximate the outlength of the curve. Okay, so this is our f. In order to find the outlength, we have to figure out what is the derivative. Well, this is Parada's rule, right? First guy prime times second guy plus first guy times second guy prime. First guy prime, derivative of x is just 1. And then derivative of e to the x is e to the x. Okay? So what's the outlength? From 0 to 1, square root of 1 plus f prime squared. So e to the x plus x e to the x squared dx. And see, we're not able to integrate these functions and get a nice formula. So the numerical methods is really awesome. It can help us to approximate this definite integral as close as we want. And so here we also have 0 to 1 because this is all 0 to 1, so the points are the same as before. So we just put it down. And so L is approximately by the trapezoid method. H in this case is also 1/4. So H over 2 becomes 1 over 8. And then, oh, I write F again. Let's call this guy G. So G of A, 1 copy. G of B, 1 copy, and then middle guys, they are 2 copies. Let me actually write down the points. So G of 0.25, G of 0.5, G of 0.75, and B is 1. So far, so good, everybody? Okay, G of 0. Square root of 1 plus e to the 0 plus 0 times e to the 0 square, right? Plus 2 copy of the square root 1 plus e to the 0 plus, 0.25. And then 0.25 times e to the 0.25 square plus 2, and then 1 plus e to the 0.5, 0.5 e to the 0.5 square plus 2 e to the 0.75, 0.75 e to the 0.75 square, and then plus g of 1 plus e to the 1 plus 1 times e to the 1. Oh, which is just 2e, right? Okay, so we write down everything, and please, in your exam, write down the formula, because if you make a mistake, I still know that you know how to do it, right? I can give you most of the points, partial credit. Okay, so let's plug into our calculator. 1 over 8. And then we have, let's see, square root of 1 plus parentheses e to the 0. Even though I know e to the 0 is 1, but I want to write down the whole thing, because later on I just change some number. So 0 times e to the 0. See, I can also copy this guy. e to the 0 and this guy square, right? And then plus 2 times, okay, now I can copy it. Okay, so e to the point, after the 0, this is 0.25, and this is 0.25, and this is 0.25. So far, so good, everybody. And here, same thing, but delete the 2 because it's 0.5, right? And then copy the same thing and paste. And the 7, 7, and 7. Last one is square root of 1 plus, let's see, 1 plus, you can also type the same thing and then replace it by 1, right? So, but I know this is 2e. Maybe replace by 1 is faster. Okay, e and square. Okay, so what is the answer? Oh, I forgot to close it. So far, so good, everybody. So the answer is 2.9667 50915. All right, now let's use Octave or MATLAB to check our work. So here we have this. We're using trapezoid. Okay, and then here we change our functions to square root of 1 plus parentheses e to the x. Oh, type the wrong number. Okay, e to the x plus x times e to the x. So e to the x is exp of x. And then this guy square. And then close it. Yes, don't forget we have to have the same number of parentheses on the left and on the right. Okay, see, the answer is 2.9668. And that matched with our results. Yay! So let me print screen and copy it down here. So this is what we type. Okay, I don't want to get that. Okay, so and paste it here. Oops, let me move it down. So you will have that in your class notes. And the answer here. Okay, so where is it? Okay, right here. Go. Come on, come on. All right. Okay. Okay, so far so good, everybody. Okay, so we can also increase the number of subintervals to get a more accurate answer. So more accurate answer is 2.9327. So far so good, everybody. Oh, what happened if we increase like 100? Ooh, 2.9324. How about if we use Simpson's method? Just, okay, SIMP. 2.9326. Okay, and if we do 40 steps, yes, 2.9324. Okay, so that is the true value is 2.9324, and then some decimals follow that. So far, so good, everybody. Okay, last example. By the way, for these examples, I really hope that you can try it first before we continue. Okay, so here we're gonna use the composite Simpsons method with n equals. Also, let's do 4 if we want to calculate by hand. We can also do 6 subintervals or 8 subintervals. Okay, we can do that. But when you cut it, just need to be careful. The points change. For the trapezoid method, n can be an even number or it can be an odd number. But for Simpsons method, the n must be an even number. Okay, so here we have the parametric equations, right? So x and y, they are functions of t. Then we have to figure out what's x prime of t. Derivative of cosine is minus sine. Derivative of sine t is cosine t. And then L is integral from 0 to 2 pi and then square root of x prime square. So minus 2 sine t square plus cosine t square dt. So far, so good, everybody. Okay, I would like to simplify a little bit. This is 4 sine t squared plus cosine t squared dt. But actually, you know what? I can split 3 sine t squared and 1 copy of sine t squared. And can you guess what happened? Sine and cosine add them together, it equals 1. So this whole thing, it is just 3 sine t squared plus 1 dt. You might say, can I use this guy to calculate? Of course, yes. But just you need more time to type in more functions and more numbers. Okay, you don't have to simplify. Okay. Alright, let's use this integral, and here we're using the Simpsons method. So we also have so 0 and 2 pi. Then the midpoint will be pi, and this is pi over 2. This is 3 pi over 2. Because we're working with trig functions, you better make sure your calculator are in radian mode. Okay, so at length, Simpsons method. Well, what is h? Well, h is the step size, right? That is pi over 2. Okay, and so Simpsons method, h over 3, pi over 2 over 3 is pi over 6. And then let's call this guy g of t, right? We have g of 0. And then 4 copy g of pi over 2. 2 copy g of pi. 4 copy g of 3 pi over 2. And then 1 copy g of 2 pi. So far, so good, everybody? Okay, 0. Well, sine 0 is 0. Oh, it's just square root of 1, which is 1. Okay, next, we have 3 sine pi over 2. So pi over 2, sine, sine function at pi over 2 is 1. 1 squared is 1. So 3 plus 1 is 4. It's actually just square root of 4, which is 2. We don't really need a calculator. See? 2 copy of sine of pi is 0. So square root of 1 is 1. And then sine of 3 pi over 2, this is minus 1, but minus 1 squared is 1. So we still have 3 plus 1 there. And sine of 2 pi is 0. So square root of 1 is 1. Ooh, you see, actually, we don't need a calculator for it. So 1 plus 4 times 2, 8. 2. 4 times 2 is 8. 1. Let's see. This is 10. Though that is 10. Oh, that's 20. 20 pi over 6. Oh, 2 is a common factor. 10 pi over 3. See, we got exact number. But let's use MATLAB to check it. In order to use MATLAB to check it, so let's calculate what that number is, and then we can check whether our calculation is right. So 10.47197, 10 point. Oops, sorry. 4719747197551. So far, so good, everybody. Okay, let's do here. So Simpson's method and our function. What is our function? Square roots of 0 to 2 times pi. And so square root of 3 times sine of t square plus 1. Okay. See, the answer is 10.472. Yay! That matched with our answer. So far, so good, everybody. Alright, so let me copy it here. Let me move it down. Okay, so when you do your homework, you can always use MATLAB or Artave to check your work for these kind of problems. Okay, so you can check your work. So far, so good, everybody. And if we increase the number of subintervals, we'll get more accurate answer. So around 9.68884. Let's increase one. Let's do 100 steps. Yes. So the answer is 9.6884. So far, so good, everybody. Okay, now I can say our calculus 2 is complete, because now even though for some integrals we're not able to integrate and get a nice formula, but we can use trapezoid method or Simpson's method to approximate the definite integrals as close as we want. Okay, we just divide it into more subintervals. Alright, so if you have questions, feel free to ask me. Have a nice day. Bye.